We have to be able to tell if this thing is a polynomial or not, right?
Yeah.
So, double check, sometimes it goes off for some reason. I hate technology. Okay. Which ones are polynomials? Okay, what about A? No. And why are you gonna say no?
It has a negative exponent.
Yep, has a negative exponent. Perfect. How about B?
Yes.
Yep, nothing wrong with B. Are we worried about the fact there's fractions in it? No. Unless the fractions are in the exponent, then it's a problem. All right, how about C?
No.
Yes. No.
Oh no, C is a big no, because why? You have,
In the denominator.
you has an X in the denominator. It has X under the radical, and it has a fractional exponent.
Yeah, that's no, 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 no.
That's a no. Okay? All right, number 2. Find the vertex, axis of symmetry, and direction of opening in the manner of your choice. So we got y equals -2, x plus 3 squared, minus 8. We need vertex, axis, symmetry, direction of opening. This is the easiest problem you've ever had in your whole life because it is in vertex form. So the idea is you can look at this and tell me that the vertex is where?
Negative
3, -8. Stop a minute and think. What does this do? X plus 3 moves you 3 to the left and 8 down. That puts you at -3, -8. What's your axis of symmetry then? X equals -3. These numbers always are the same. Always, 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 always.
Drop an X.
And which way does it open?
Down.
Down. Second one isn't quite as easy because it is not in vertex form. So how do we find this vertex, axis of symmetry, and direction of opening? Exactly, -b over 2a. That's our little axis of symmetry formula. So in this problem, it would say -b, -8 over 2a, 2. So that's -4. So your axis of symmetry is x equals -4. Now, what does that mean about my vertex? X is -4.
Yeah.
And then how do I find the y? Plug it in. So let's see, -4 squared is 16. 8 times -4. Alright, what's all that add up to?
That's negative 20.
-20. There's the vertex. Which way is it open? Up, because the x squared is positive. Easy. All right, write the equation of the linear function where f of 3 is 1 and f of -1 is 9. So what are these? What's this? This is just a fancy way of saying 3 comma 1
Yeah, points.
points and -1 comma 9, right? Write the equation of the linear function. So it's a line. So what do I need to know?
Slope.
Find the slope. So slope, if you miss this, so help me God, I think I will smack you. Slope is y minus y over x minus x. 9 minus 1, -1 minus 3. You know how to find slope. So what is that? -2. That's our slope. So now what?
Take a point.
Pick a point. I'll just use this one, doesn't matter, pick one. And then y minus the y equals slope times x minus the x. Y minus 1 equals negative 2x plus 6 when I distribute. So my linear function y equals negative 2x plus 7.
Yes.
Alright, quiz has these 3 problems on it. Might be in a different order because we have different versions of the quiz, but those are our problems. Those are also the kinds of problems that are in your homework. So if you haven't yet done the homework, do the homework as extra quiz practice. Alright? Put it away.
When is the quiz? Monday?
It's our next class. Whenever our next class is, that's when we're having a quiz.
Are you gonna be at noon?
What are we meeting?
Alright, 2.2. Notes, 2.2, here we go. Write an equation for the following. There's more than 2, but we're only going to talk about 2 kinds of variation. We're going to talk about things that vary directly and things that vary inversely. Well, Mrs. Ford, what's the difference? Well, I'd like you to think about this situation. I love bananas, okay? So I go to the store and I buy bananas. The more bananas I buy, the more money I have to pay. Would you agree with that? So as my bananas go up, my money goes up. You go to the gas station. The more gallons of gas you buy, the more money you have to pay. Both variables, both things, are moving in the same direction. If bananas go up, money goes up. Now, think about this. I'm going to drive to school. If I drive to school today at 30 miles an hour, it takes me 20 minutes. If I drive to school at 40 miles an hour, it takes me 15 minutes. So what's happening? As my speed goes up, the time it takes me goes down. You see the difference? One quantity is increasing and the other one is decreasing. That is called inverse variation. If they're both going the same direction, it's direct. If they're going opposite each other, it is inverse. Okay? So, what are our equations look like? Well, it's very simple. If things are direct, the format is going to be y equals kx, where k is the constant of variation. You'll understand that in a minute. Right now, we're just getting the formula. Y, this is problem A. Y varies directly as x. This is the equation for that. Y varies inversely. This is problem B. Inversely is y equals k over x. So in this little unit, you have 2 things to remember. That's direct, that's inverse. So then I go to problem C. P varies directly as the square of Q. Now it's direct, so it's going to be this format. But instead of y varies directly as x, it's p varies directly as the square of q. So what's the equation? P equals k times q squared. If you're varying directly, it's k equals. Well, how in the world? I have no idea. So I don't know what to do about that.
That just happens.
Yeah, it's an idle mode.
Oh, so nothing,
Yeah, nothing. It's just idle.
I'm in the wrong room now, so that's why that didn't work. 43, 44 is the other one. All right, so when it's directly, inversely, it's gonna be whatever it is, in this case it's P, equals K times whatever. So what is D gonna be? Well, it's gonna use this model. So D is gonna say M varies inversely as the sum of A and B. Height varies directly as weight. Height varies directly as weight. Does that make sense to you? Remember, if it's direct, it's K times. If it's inverse, it's K over.
Proportional.
Yes. Now, F actually uses the word proportional. Proportional is another word for direct. So we just gotta remember that. Proportional is another word that means direct variation. So it'll be this. It'll be this. Because doesn't it say Y varies directly as X? Which is the same as our original problem was. So F is the same as A, just using a different word. Rate is inversely proportional to distance. So rate is inversely proportional to distance.
Will you accept the whole word?
Alright, is that okay with everybody? Now let's do a couple problems. I think you're gonna find these easy. We have to remember this relate these two things right here. Okay, so read the question in number 2A and write for the first sentence, write an equation for that. Temperature is directly proportional to volume. Does that make sense to you? Okay, that's the first sentence. The second sentence says, if the temperature is 70, the volume is 30. So my first sentence, I wrote my equation. My second sentence, I plugged in the T and the V that they gave me in the sentence. Would you agree? Now, what am I gonna be able to do now at this point? What am I gonna be able to do?
Divide.
I'm gonna be able to find K. So K is gonna equal 7/3, 70 over 30. And I would just leave it like that, don't worry, it's fine.
You want to simplify?
This is simplified, stop right there, just leave it. Now, what does the last sentence want? Find, go back to here, find the temperature when the volume is 20. But remember kids, don't we know K now? So in our formula, we're gonna find T, but we know that K is 7/3, and we know the volume, or whatever V is, volume is 20. So now we will multiply 7/3 times 20 over 1. I am fine with the fraction, I'm fine with the decimal, I'm fine with the mixed number, however you want to write it. It's easiest just to leave it like that. But whatever you want to do, that's your T value.
So I was confused how like the 70 and 30 get shrunk down to 73. It's just the same.
Divide by 10.
Okay.
Reduce the fraction. Yeah. Cancel a 10 out of it. Okay. All right, let's try B. Same thing. B. Volume varies inversely as pressure. Somebody tell me what that looks like. Volume varies inversely as pressure. Megan?
E is equal to K over P.
V. Yeah, V equals K over P. What do the rest of you think? Is she right?
Yeah.
Beautiful, beautiful. Step one, write your equation. I promise you, there will be one of these on our test. Not our quiz, we already know it's on our quiz. But on our test, there will be one of these. It will be written exactly this way. So sentence one, write your formula. Okay, so then what? What's sentence two say? If the volume is 200, the pressure is 40. So look at that. What can I do now? What does this tell me? Won't this tell me what K is?
Yeah. How about 40?
So multiply both sides by 40. So K is going to be 8,000, I think. You can use a calculator. That's a big number. So now we know what K is. K is not the answer to the question, but we know what it is now. Find the pressure if the volume is 950. So 950 equals 8,000 over P.
Yes.
And then, be careful, to solve this, you've got to get that P out of the denominator. So 950P equals 8,000. You can't solve that, kids, you've got to get him out. So 950P equals 8,000. And then we'll divide by 950. And then those are way too big for feeble Mrs. Ford, so we'll just type that in.
I got 8.42.
8.42?
Yeah.
I'm taking your word for it, you better be right.
He's right.
8.42?
How do y'all put a label? Or no? Like,
It doesn't give me labels on the problem. If it did, we would, it doesn't, it's probably degrees, but
Yeah.
I don't know. All right, guess what, folks? 2.2 done. So that homework will be due on Friday. Okay? So it took us not very long to get through that short little lesson. The homework isn't going to take you very long to do that. That's due on Friday. Is 2.1 due tomorrow?
Yeah.
Yes, we finished it yesterday. Yes. Okay. All right, so now we're going to start 2.3. This you're going to love. You're going to enjoy this. But there are a couple things we have to talk about. All right, so we're going to sketch this. We're going to do it without our calculators, so I don't want to see anybody typing anything on the calculator. When we're done, we'll check it on our calculator. But we're going to learn how to graph this by hand, and it's so easy. Okay, all right, here we go. First thing I want you to notice is the problem is beautifully factored for you already. The factors of the polynomial, this is a polynomial, if I multiplied it out, it would be an x cubed, right? The factors of the polynomial give me my zeros, which are my x-intercepts. So I know that I'm going to have a dot on my x-axis at -1, a dot at 2, and a dot at 3. So we begin our problem by plotting our x-intercepts. They're called zeros. And where do they come from? They come directly from the factors. And notice, like everything else we have done all year, if I'm taking a number out of the parentheses, it becomes the opposite, right? So this is -1, +2, +3. Okay? Now, I need you to dig back in your memory banks. If I multiplied this out, would everybody agree that it would be an x cubed? Plus some other stuff, but it would be an x cubed. X cubed is one of our BFFs. What does x cubed look like?
It's the like half X. It's the
It's like the snaky thing, right, that comes up and squiggles through and does that, remember? Every cubed equation that you draw is going to have that kind of end behavior. In other words, it's gonna start down here, it's gonna do whatever it does, and it's gonna end up here. So when I graph this, I know I'm coming up from the bottom. I'm gonna pass through that point, but at some point I have to turn around because I have to connect to that one. All of our points are connected. So I know I'm coming up from the bottom. How do I know that? Because it's a cube, and that's what cubes do. So up from the bottom, come up. I don't care how high you go up. Come down, pick up this point. I'm gonna go through that one. Then turn around and connect to that one and shoot off into space. And you just sketched it. That's what it looks like. We're done. Without a calculator or without plotting a bunch of points, I don't know how high this goes or how low this goes, and I don't care. We don't care at this point. We just want the general shape, and that's the general shape. All right, let's get our calculator. Zoom 6. Make sure you zoom 6 to start. That's going to give you a nice square screen. Then type in y equals this equation right here. Type it in with the parentheses. So x plus 1, x minus 2, x minus 3 with the parentheses, and just hit graph. Do you get something that looks similar to this? It's not gonna be exact, but is the shape the same?
Yeah.
That's what we're looking at. Yeah, the same shape.
Just like in
Zoom 6.
type it in right there, like y equals.
6.
You type in this.
Oh,
Type in, like you did, y equals.
Okay, everyone?
supposed to be like
Zoom 6.
that
Zoom
was a
6.
series of lines.
That's okay. Yeah, I'm not sure why that does that. Now, important point. Important point. This was a cube. We said cubes start down and end up. That behavior, start down, end up, is every odd degree function. So if this were an x to the 5th problem, start down, end up. X to the 7th, start down, end up. Any odd degree polynomial is going to behave just like this. Wait, we'll get to that in a minute. All right, everybody hear that? Okay. So, without my help, would you try letter B? Without my help. Try B. Is it exactly the same kind of problem as A?
Yes.
Yep. Your dots are in a different place, but you're going to start down here and connect them in exactly the same way. Always label your points to this, so when you plot these points, make sure you are labeling them. You should have dots at -4, -3, and +2. You should be down here, coming up. That should be the shape that you come up with. Remember, your dots have to be connected. So when you come up, you gotta turn around and come down, because you gotta connect to this guy. And then you gotta turn around and come up and connect to him. That window is not quite big enough for this problem, but you should be seeing something that looks similar to this. If you're doing it on your calculator. All right. Tell me what's different about the next problem.
They have exponents.
it has an x squared in it. Yeah, it's got a squared factor. All right, let's talk about this. First of all, where will the dots be on the x-axis? Gonna have one at -1, always label one, and one at 3. If I multiplied this all out, would it still be a cube?
Yeah.
Yeah. So it's still gonna start down here, kids. This is where cubes start. All odds start down here. Now here's where you gotta pay attention. What shape is that? Forget all the rest of it, just this right here. What shape is that? That's a parabola. So when you have a squared factor, it acts like a parabola. So in other words, when it hits here, it's gonna turn around and go back down. It's not gonna cross through, it's gonna like bounce off. Because that 0, -1, that x-intercept, is squared. So it's behaving like a parabola. So it bounces off and comes back down, and then it has to turn around because it's got to go through that point, and it shoots back up into space.
So it doesn't matter like which way the parabola is facing this.
No, I see what you're saying, no, because it would be positive. Yeah, no, it bounces off, wherever it hits, it bounces off. All right, so it's gonna bounce off wherever it hits. Now, this -1 is the bounce point. 3 is not a bounce point. You only bounce if your factor is squared. Got it? All right, type that one in on your calculator. Let's see if you got that shape. You should be able to see that one just fine on your calculator. Yeah, that's what you get. It takes longer to type it in than it does to graph it. These are easy to graph, right? All right, let's look at the next one. Now, what's a little different about the next one, you guys?
Equals to 4.
Okay, so since I have 2 squares, this degree would actually be x to the 4th if I FOILed it all out. All right, so stop. All this talk we had previously, start down here, end up here. That works with odd degree. So x to the 3rd, x to the 5th, x to the 7th. Start down here, end up here. What happens when it's not odd? Well, when it's not odd, I want you to think about x squared. That's not odd, right? That's a square. What does that look like? Well, so it starts up and ends up. When you have an even degree, any even degree, you start up and end up. That's what even degrees do. So when I graph this, I'm only gonna have 2 dots. I'm gonna have a dot at -3, and I'm gonna have a dot at 2. There's only 2 dots I'm gonna have. Did everybody agree with that?
Yeah.
Dots come from the parentheses. Actually, that could have been my phone. No one ever calls me, so I'm not sure. Nope, it wasn't. It's someone else's. Okay. Now, what did I say? Even degree, start up, end up? So I'm gonna start up here, and I come down to this point. Now, that point came from this factor, and that factor is squared. So what is my curve gonna do? It's gonna bounce right off.
Bounce it up.
It's gonna come around and come back down. What's it gonna do when it hits that one? It's gonna bounce right back up. So this curve
W.
is going to look like a W.
Hey.
We have talked about 2 super important things that you need to remember. First of all, if you multiply out your whole problem, and you'll never have to do that, but mentally, multiply out the whole problem. If you get x to an odd number, we call that odd degree. you're gonna start down and end up. That's how it acts. If you multiply it all out and you get an even degree, x to the fourth, x to the sixth, x to the second, it's start up and end up. Okay, so that's one important thing. The other important thing is, if you have factors that aren't squared, the curve just goes right through. Just, if though you have factors that are squared, it bounces off at those points. Whatever direction it came from, it bounces off and goes back. Got it? All right, we'll see. Let's look at E. You didn't realize when you came to school this morning that you were going to learn something so cool. Who would have thought that you would be able to graph this by hand? So tonight at supper, when your parents say, what did you learn in school today? Whip this out and they'll think you're smart. All right, here we go. Where do the dots go? So -5, I've got one. -1, I've got one. 2, I've got one. Would everyone agree with this? All right, if I multiplied all this out, and you're never gonna have to, so don't worry about that. But if you multiplied all that out, what would be the biggest power? X to the fourth? Fifth? Eighth? Fifth? We're gonna start a fight up here. What do you think? It's 5. How many x's are in the first factor? 2. How many x's are here? 2. And how many are here? 1. That makes 5. This is x to the 5th. 5 is an odd number. Odds start down and end up. So I'm going to start down here, come up to this point. Very good job. All right, when I get there, I have a decision to make. I'm either going to go through or I'm going to turn around and come back. So that came from here. What am I going to do? Go through. Now, at some point, I got to turn around and come back down. Would you agree with that? Now I have a choice to make. What am I going to do? Well, that came from here, and that one squared, so I'm going to bounce back off the way I came, turn around and come down, and then I'm going to bounce again. Now, again, guys, how high up you're going, don't worry about that. Just get the general shape figured out. Yes. I mean, it matters it's going in the right direction, but how high it is and whatever doesn't matter. All right. Oh no. Look at the next one. What is different about this?
Cubed.
Now I have a cube factor. All right, so let's take care of what we know. What we know is we have a dot at 3, we call these x-intercepts, right? And 1 at -1. Would everyone agree with that? What is the degree of the polynomial? In other words, multiply it out and it would be x to the 4. Guys, x cubed, plain x. That makes 4. 4 is even. Even means start up and end up. So I'm going to start up here. Now, what am I going to do when I get to this point right here?
Go down.
Keep on going. Keep on going. So here I go. Keep on going. Now, I'm going to turn around and connect to 3, 0. But because that factor is cubed, it's gonna behave just like a cube. So it isn't going to shoot straight through, like this one did, just come straight through. It's going to curve its way through, squiggle its way through. So I'm gonna come down, I'm gonna turn around and squiggle my way through that point. A plane factor with no exponent, zip right through. A squared factor, bounce off, same direction you came from. A cube factor is going to squiggle through that point. Yep. Okay, everybody keeping up? Learning lots of things today. All right, let's look at G. Tell me where the dots go in G.
-2, -1, 3.
So I've got one at -2. I've got one at -1. And I've got one at 3. Would everyone agree with that?
No.
Why not?
-2 in front.
Now, the dots come from the X's. So if you have a random number thrown in there, now that number is gonna mean something, but not in terms of dots. The dots come from the X's. So if I have in my problem, if I have that parentheses, this parentheses, and this parentheses, that's 3 X's, 3 dots. No. Let's talk about with the first, let's back up. How many X's are in this problem altogether? There's 3 dots, but there are actually X to the 4th. So how does X to the 4th behave? Up, up. Unless
It's inverse, so.
you put a negative out in front of it. What does a negative do out in front of our problem? Turns it upside down. So if it started out looking like this, up, up, that's what 4ths do. It's now gonna be down, down, because we turned it upside down. This negative acts just like all the other negatives out in front. When you have a negative in front of your problem, it turns it upside down. Now, the 2 also stretches it vertically, but we're doing a quick sketch, so you don't need to worry about that. You need to worry about the negative, but the number itself, you don't have to worry about. The number does not get graphed, it doesn't get plotted. It would impact the points if I were plotting points. I'm not. I'm just drawing the sketch. So we have determined that it's a 4th degree turned upside down. So it's gonna start down here. What does it do when it hits that factor? Now pay attention. That dot came from here. So what do? Go straight through. Why do I go straight through? Because there is no exponent on that factor. Okay, so I gotta turn around and come back. Alright, now what do? Well, that came from this factor. Well, there's no exponent on it either, so straight through. I'm gonna come down and come up and get that one. What do I do when I hit that one? Well, that one has a squared, so I'm gonna turn right around and come back the way I came. Look, did it behave the way you thought it would? Yeah. Remember when we did an X to the 4th a little while ago and it was a W? Well, we turned it upside down, so now we have an F. Alright, with your partner, would you see if you can sketch, H? Now, guys, what attention are we paying to the 1/3? None. Very good, none. Now, the negative we're paying attention to. But the 1/3 is not impacting our sketch. Because I'm not building a T-chart and I'm not plotting points. If you can do this problem, you have pretty much learned what you're supposed to learn. So take a minute and get it sketched. Hurry up.
No. Yeah, not me.
Turn down.
What makes you
Can somebody tell us what the first thing you did was? Where do we start? With the dots. I am so unmathematical. We plot the x-intercepts. So we should have one at -2, at +1, and at +3. Groupies, that's where you gotta start. Alright, you gotta have those points on there. Okay, what's the next thing you thought about as you were graphing this? How many x's you have?
So it should go up because negatives.
Okay, so Megan says, I've got 3, 4, 5, 6 x's. Everybody counting 6? That means up, because evens are up. But as she pointed out, got a negative out in front. So this one's gonna be down. So it's gonna come up from the bottom. Oh, gotta be careful. Why do I have to be careful with that one? That's a cube, so I need to squiggle my way through that one. So I'm gonna come up and squiggle my way through there. And I'm squiggling because it's cute. Alright, so I'm gonna come up, come down. What do I do when I hit that point? Straight through, because it came from that parentheses. You gotta pay attention what parentheses it came from. There's no power on that, so it goes straight through, turns around.
This one bounces up now.
That one is going to bounce off. And there you go. Now that's not a W or anything, or M or anything, because it's a 6th degree polynomial. You guys just sketched a 6th degree polynomial. It's pretty impressive. Pretty impressive.
How often will you do 6 degrees?
Okay. All right. We're going to try one more problem and then we'll be done. Number 2, backwards. We are going to write an equation. So we have the picture and we're going to write the equation. Now your equation, here's an example. This is what it's going to look like. It's going to have a bunch of parentheses in it. Okay, can you tell by the picture what the parentheses will be? X plus 2, X minus 1,
And then X minus 3.
X minus 3. Now I want everybody to look at that. Can you figure out from the picture that those are the parentheses?
Wait, what's 0 2 for?
Hang on. It's not a point on the x-axis, so it's not a parentheses. The parentheses come from the points on the x-axis. That's how you put them there, right?
Yeah.
They came straight from the parentheses. Okay. Now look carefully at your curve. Because now I gotta put powers on these. what is the curve doing at that negative 2 point? Isn't it going straight through?
Yeah.
So that tells me that there's no power on here. Alright, what is it doing at the 1?
Parabola.
It's bouncing, so don't I need to put a squared on that one? And then what about the 3 point? What's the curve doing?
Nothing.
Nothing, straight through. So now I have my powers on there. Take a look at this equation that we just graphed. What is the only thing missing? Well, I need a negative, but I don't know what number's out there, right? Could it be a -2 or a -1/3 or a -18? I don't know. So I'm gonna call it A. Oh my gosh, does this look familiar? I'm gonna call it A. I don't know what that is. I know it's negative, but I don't know what it is. How did I figure this out yesterday?
We took a.
I took the other point that I was given. So Keith, what other point was I given?
0, 2.
0, 2. And my x is 0 and my y is 2. So 2 equals a times, okay, 0 plus 2, 0 minus 1 squared, 0 minus 3. So 0 goes in for every x, and 2 goes in for y. 0 plus 2 is 2. 0 minus 1 is -1. Squared is 1. And 0 minus 5. So 2 equals a times, all multiplied, -6. So a equals 2 over -6, which is -1/3. So we wanted our equation, just make that a -1/3, and that, my friends, is your equation. How easy is that? We'll do the rest of them tomorrow. All right, so we got a lot going on. We got some homework due tomorrow. We got,